All right, in this video, we're going to discuss how to simplify rational exponents. You were probably taught that in order to simplify a rational expression like this one, that you would basically ask the question, what number do I have to multiply by itself in order to get the radicand here, which is 64? So what number multiplied by itself gives you 64? Well, of course, the answer is 8. 8 squared, or 8 times 8, will give you 64. So you were probably taught to say, okay, that means the answer to this problem is 8. And there's nothing wrong with that thinking. That's absolutely correct here. However, we want to demonstrate a technique where you use factoring to arrive at the same answer. And why do we want to do that? It's not because we want to make our lives complicated, but it's because we essentially want to be able to handle problems that are difficult. And when we can't figure out the answer to the question, what do we multiply by itself to give us, 64 in this case, we can't answer that question for ourselves easily. Factoring is going to help us see the answer in a much more fundamental way. Okay, so what I want to do is I want to take the radicand, which is 64, and I want to say basically, can I come up with any two things that multiply to give you 64? They don't have to be the root of 64. Like, we don't have to say 8 times 8, right? Maybe you didn't know 8 times 8 gives you 64. Now, probably you did because it's in your times tables, but what if you didn't know it? What if it was a number you're not familiar with enough to know its square root? So if that's the case, then you could at least find two things that multiply to give you the number, perhaps, right? So for example, 64, I can see that it's even, and all even numbers can be written as 2 times something, right? So maybe 2 times 32, for example. And this number is prime, so I sort of stop there and I say, okay, I can't break down 2 any further, so I'm going to circle it, just kind of indicate that that part is done. But 32, I could still break it down further. So basically, we're trying to find factors, right? So what are the factors of 32? So can you give me any two things that multiply to give you 32? Well, I might say, I know that 2 times 16 is 32. Or you might have said 8 times 4 is 32, right? It doesn't matter which you choose as long as you choose something. So 2 times 16 is good. I could then say that, hey, 16 is 4 times 4 if I wanted to. Or I could keep going with the 2 theme and say, well, 16 is what? 2 times 8, and then break down the 8 from there. But at this point, I wanted to deviate a little bit from that and say, okay, well, I know 16 is 4 times 4. Now, 4 can be broken up as 2 times 2. So 2 times 2 gives you 4, and then that's actually done because we can't go any further than 2 times 2. We can't break 2 down any further. And likewise, the 4 is also 2 times 2. So now we kind of closed off all the branches. We can't go any further, right? The 2's don't factor any further than just 2. They're prime. All right, so how many 2's do we have circled here? Well, it looks like we have 1, 2, 3, 4, 5, 6 2's together. Okay, so what we know then is 64 is 2 times 2 times 2 times 2 times 2 times 2. So I could actually write that out if I wanted to. I could write out 6 2's multiplied together under the radical. And that would be the same as saying the square root of 64. Okay, so why would I want to do this? Well, the reason why is because there's an index on this radical. It's unwritten here because it's assumed to be 2. So I've tried to write it in there so you can see it. An index of 2 means we're doing the square root, correct? It's the square root. What it means is that for every pair of values you have under the radical, you can take out 1 outside of the radical, right? So what I'd like you maybe to think of is like if this square root was like a prison cell, right? If it was a prison cell, it would be hard to break out of the prison cell. But let's say if you had a partner in crime, right? That partner could help you break out, and then you might escape. But of course, maybe only one of you gets out because on the way out of prison, one gets shot. It's a dangerous thing escaping from prison. So it's just a helpful little metaphor to make you think of how to take out these factors. So 2 times 2, for example, they have a partner, right? They're identical. And since the index is 2 for this radical, it means that anytime we have 2 present, we can break out of the prison. But only 1 makes it out, right? So that's 1, 2 outside the square root. Now there's another pair of 2's here. So again, they have a partner, then they can break out, right? So another 2 will come out. It takes 2 2's to get one of them outside, right? And then we'll have this pair of 2's. Again, they have a partner, so 1 can get out. And so there it is. We have 2 times 2 times 2. And there's nothing left under the square root, right? We've eliminated everything inside of here. So all we have left then is 2 times 2 times 2, or in other words, 8. Now you may say, my goodness, that was a lot harder than just saying what two numbers multiply to give you 64 that are exactly the same. Or in other words, what number times itself gives you 64. Well, I know that was a lot harder, but it was a lot harder for this problem because the square root of 64 is easy. It's something you know from your times tables. But what if it was something you didn't know? What if it was something you weren't familiar with? And it turns out that this method, although it seems long, will actually be a way you can arrive at the answer without a calculator and being able to figure it out, even if it had something like variables in it. We can use the same underlying structure or logic to solve the problem. All right, let's look at another example then. So let's look at example B first. So this time it's the third root of 64. So this question would be, what do you multiply by itself 3 times to give you 64? So what I want to make you think of again is this idea of factoring. So let's not try to do the problem in our heads, even though it is doable in our heads. We could think about what number times itself 3 times gives you 64. What I'd rather you do is to try to factor 64 into any two things that multiply to give you 64. So for example, you could say, well, 64 again is 2 times 32. And just like we said before that, okay, well then 32 broke down to be what? You could say 2 times 16, right? And then you could even say what? 16 is 2 times 8. And then 8, of course, is 2 times 4. And then you know that 4 is 2 times 2. So all the branches are terminating at 2 again. And then at that point, you'd be able to say, all right, so 64 again is 2 to the 6th power, or in other words, it is 2 times 2 times 2 times 2 times 2 times 2, 6 2s all together, right? Okay, so you have your 6 2s, and then what we want to do is say, well, what's the index for this problem? Well, it's a 3 this time. The index means it takes 3 of these guys under the radical to take 1 outside of the radical, right? So you can think of it, if we use our prison analogy again, this is like a maximum security prison. It's harder to break out of. It takes 3 partners in crime to be able to escape, right? And of course, only 1 makes it out alive, right? So we're going to say, okay, here's 3 2s. We'll cross out the 3 2s and take 1 outside. Here's another 3 2s. That means we can cross out those 3 2s and take another outside. And 2 times 2 will give you the answer 4. All right, so I know it probably was easier in your head maybe to say, well, 4 times 4 times 4 gives you 64, and you could have answered it easier that way. But again, that's because you're familiar with 64. What if it had been a number you weren't so familiar with? All right, let's take a look at our last example. This is C here. So for example C, first of all, we have a negative underneath. That's okay for a third root. It's possible to have a negative root when you have a third root, or any odd root for that matter. All right, so we know that we're looking for a number times itself 3 times. That gives you 216, but I want us to use the factoring method because maybe you're not familiar with what number times itself gives you 216. So what we want to do is try to find something that will go into it. So it's always helpful to remember that even numbers always have a 2 in them. I want to teach you another trick as well. If you add the digits of a number together, like 216, if you add those digits together, in this case we get 9. If the number that results is divisible by 3, it means that 3 will go into the number. If it's divisible by 9, it means 9 will go into the number. That trick works for 3 and 9 only, so don't try it for the other methods, but it works for 3 and 9. So what we're saying here is because the sum of the digits in 216 add up to 9, we could certainly divide that number by 9. We could also divide it by 3, right? Those things will go into it. And, if it's even, 2 will go into it. So we have lots of things that will go into this problem. So let's go ahead and just try putting the 2 in, because I know that was simpler for most of us probably. So we'll start out with the idea that 216 can be broken up as 2 times 108. All right, so 2 times 108 will give you 216. 2 is prime, so we can circle that. What about the 108? Can you find any two things that go into that? It's still even, so I can still say what? 2 times something. In this case, it would be 2 times 54. So the 2 is prime, so we have that. All right, now from there, let's think about factors of 54. It's still even, so I can certainly say what? 2 times 27, if you know that that's the case. If you don't know that's the case, you can do 9 times 6. 9 times 6 gives you 54 from your times tables. But either way, 2 times 27 works. Now, 27 is certainly 3 times 9 from our times tables. So I can circle the 3 here. That's a prime number. And then 9 is what? 3 times itself, right? So now we have all the factoring done. This number is basically the same as saying the third root of negative, because it's negative, right? 2 times 2 times 2 times 3 times 3 times 3. Okay, at that point, you'd be able to look at it and say what? Well, remember, for something that has a third root, it takes 3 of them, 3 partners in crime, to get one outside alive, right? So we're going to say that, first of all, we can bring the negative out anytime we want because that's like a -1, and you can always take 1 out of the radical, right? So we'll take out that negative sign. Then we have the 3 2's, and we'll basically be able to say that because there's 3 of them, we can take 1 outside. Then that'll multiply by a 3 because we have 3 3's, and the 3's can then come out represented as 1 3 outside. And the final answer then is -6. So of course it turns out that 6 times 6 is 36, and 6 times 36 is 216. So that actually was how we could have done the problem if we had realized that 6 cubed is 216. But if you didn't know that, and you didn't want to use a calculator, or you couldn't use a calculator, this method would work perfectly. Now again, I'll remind you, there are going to be problems you cannot use your calculator for because they involve variables. There'll be problems where the root isn't perfect and you're expected to still simplify it. This factoring approach is going to handle those problems for us, so it's not something you should ignore. It's something you need to know how to do.